We use some kilowatts of power to make the rotor spin to create megawatts of power to pull the ship forward. We're really talking about megawatts because at times the power of the sails can be even higher than what's coming out of the main engine. So mid-sized tanker in our fleet does 8 knots with our two sails only. I think this is a significant speed, what we talk about here.
Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Heikki. Heikki, welcome to the podcast. Would you like to introduce yourself?
Hi, Tom. Thanks for having me here. Yeah, my name is Heikki Pöntynen. I'm the CEO of a Finnish cleantech company, Norsepower. I'm also a naval architect, marine enthusiast, and very concerned about the well-being of our planet.
Okay. And tell me a little bit, Heikki, about your professional journey into where you are today.
I come from a family of long traditions in the maritime industry. My family has been building ships since 1600s already, and I'm a third generation of naval architect in the modern era. I've been in the marine industry for 30 years of my life, lived in different parts of the world, been in different parts of the value chain, working for a ship owner, as a shipyard CEO, equipment manufacturer, engineering company, turnkey company. So seen really the cross cut of the industry in my history. And now actually very nice to be with a cleantech company, a completely different perspective that I've had before actually into the industry.
And tell us a little bit about Norsepower. You say it's a clean tech company. What is it that Norsepower is doing?
Norsepower is bringing sales back to shipping. Our product is an invention that was made 100 years ago. It's called a Flettner rotor, a rotating cylinder that acts like a sail, bringing the ship forward. So sailing is what we do actually, and produce sails to ships.
It's interesting that you're based in Finland, just given that 95% of ships today are manufactured in China, Korea, or Japan. So how come you're based in Finland and not in one of those countries?
Well, actually, the Finnish maritime industry is extremely strong. The ecosystem in the country is what 600 company. It's almost 10 billion euros industry in the country. We're building the biggest cruise liners in the world, very specialized ships like icebreakers, research vessels in Finland. So the maritime industry and the ecosystem in this country is very strong, and that also triggers innovation, of course, into the industry like ourselves producing now sails.
Okay. And why, just taking a big picture view here, why has the shipping industry in general been so slow to decarbonize compared to other sectors?
Well, I mean, from my perspective, I could say that we are somewhat old-fashioned, very traditional industry. The profits have not been very good in the history. So unfortunately, fortunately, the bottom line has a meaning in this industry. Companies need to make profits in order to be able to leverage other aspects like sustainability, environmental aspects. But having said that, I mean, it's not only the dollar on the bottom line, it has something else to do. I mean, we have a new generation coming up into the industry. We have very environmentally conscious people now growing up and taking higher positions. I mean, maritime transportation is part of the intermodal journey of transporting goods, and the sea leg has to also carry responsibility of this, if I would call it, a green corridor. So all other aspects in sustainability, corporate social responsibility has to play a more significant role in the future.
Okay. And do you think the IMO's net zero by 2050 target is realistic, or is it wishful thinking?
We think that it is realistic. I mean, all industries, it's not only IMO. I mean, many other industries are moving towards the same target. And when we do it together, it is possible that we can achieve that.
And what about the levers that we have for maritime decarbonization? Where do you think wind propulsion comes in that kind of hierarchy?
Wind propulsion is sort of, it is a capex, it is a capital investment that has a payback time. It is sort of a different ballgame instead of, or in comparison of having alternative fuels, biofuels, which in turn today not so widely available in the scale that would be required. They are quite costly. The efficiency of those fuels are not that great at the moment. But in combination, together with wind-assisted propulsion, for instance, we can create sort of a tandem to be able to really make a significant impact on the reduction of the emissions. And I mean, sales alone can reduce the emissions and the fuel consumption from 5 to 25% or even more. It is sort of a joint effort with different type of measures and means in the industry.
Okay, and that 5 to 25% range, what influences that?
Well, actually, the trade pattern of the ship has a significant role. Where the ship sails and what type of winds do you have in the area? And of course, the number of sails installed on board has a meaning. So if the ship sails in environment where have strong side winds, that is the best environment for our product, really to make an effort and impact on the ship's fuel economy.
And we should talk a little bit about your sails, because for people who are not watching this video but listening to the audio, they can't see the ship behind you. And so when we talk about sails, people traditionally think of cloth sails, or when you talk about wind-assisted sailing, we've seen other companies who might have things like very large spinnaker type sails, almost like big parachutes pulling the ship forward. Your technology is different. So walk me through that a little bit. It's these kind of cylindrical towers, metal towers on the ship, which, as you say, are spinning themselves. How does that work?
All right. The product itself, or in the invention, is called a Flettner rotor that originally invented 100 years ago. Our tallest cylinders are 35 meters tall. It has a composite rotor that rotates around a steel tower, making like 200 rounds per minute. And that phenomenon is called a Magnus effect. It creates a higher pressure on the other side of the tower and lower pressure on the other side of the tower. A little bit in a similar way as an airplane wing does. So the air goes longer journey on top side of the wing than on the bottom side. And in layman's terms, I could say that, I mean, if you play golf, at least what happens to me, when I tee off the golf ball, it takes an unfortunate spin and disappears into the woods. And it's the same phenomenon. It makes a curve because of the pressure differences on different sides of the ball. So just make a point here, actually, because this is not a generator. That's a misconception that many people have. We use small part of the ship's electrical power to make the rotor spin, and this spinning effect creates this sort of pressure difference to push the ship forward. And actually, I mean, to talk about kilowatts, I'm not going too much into the physics, but we use some kilowatts of power to make the rotor spin to create megawatts of power to pull the ship forward. We're really talking about megawatts because at times the power of the sails can be even higher than what's coming out of the main engine. So mid-sized tanker in our fleet does 8 knots with our 2 sails only. I think this is a significant speed, what we talk about here.
Indeed, indeed. And when you talk about a golf ball, obviously golf balls are kind of dimpled, and that helps, with that effect.
Right.
Are the surfaces of your towers also kind of dimpled or in some way patterned, or do they have something on them that increases the Magnus effect, is I guess the best way to put it?
Actually, we've done some research about this, and we've seen that the quality of the surface doesn't really make any big difference on that. The same thing is with football, for instance, or basketball, or whatever type of thing that you make spin. It takes a curve effect. When the surface was very, very clear or smooth, or a golf ball like, it doesn't really make a huge difference on the equation.
Interesting. And what's the biggest myth that you hear about rotor sails or wind-assisted ships?
I already touched upon the issues. Many people at first instance think that it's collecting electricity. So it's like a generator. Wind makes it spin and we collect the energy. This is the first thing I need to really explain to people, that it's exactly the other way around completely.
Okay.
And the second thing is actually that it is a tall tower. So people might think that what about in high winds and ship stability? How does that affect the overall performance of the ship? Is it scary or not? Actually, I would say that it's on the contrary. We've seen one of the ships in our fleet that sails in the North Sea had exactly a stabilizing effect on the rotor sails. In very rough seas, in poor weather conditions, the ship set sails and went off to the ocean. And what happened is that the ship was pretty okay with the wind, with the sail effect on the ship, whereas some other ships stayed in the port. So in turn, it has a stabilizing effect on the ship's seakeeping ability.
Interesting. And if the system is so effective, why aren't more vessels already using it?
We're in a situation when the industry itself is pretty much doubling everything. What's happening now is that the fleet powered with wind-assisted propulsion, whether it's a rotor sail or other solution, the amount of those ships are doubling year on year. And of course, there is a very healthy push from different regulatory bodies of the world, giving a sort of a kick and trigger the interest of the operators and the ship owners. They would have to do something to save the planet and save emissions, save fuel, and take measures to overcome the regulatory framework.
And you said that the fuel or emission savings are between 5 and 25%. Is that data coming from yourselves, or is it coming from the ship owners, or is it a combination? Where are you getting those numbers from?
Well, the data comes, we always rely on third-party verified data. So this is something significant. What we do in our with our desktop studies is completely different when it comes to the full-scale measures and third-party verified results. So we have in our fleet already collected 500,000 hours of data stream. So along with the product that we call True Performance, it's a sort of a mixture of sensor technology, automation control, artificial intelligence, and in combination with all these, we can measure the output, the thrust from the propeller in combination with the wind-assisted propulsion. So we can really see what's the true performance, what the sails are giving. And that in turn is it then to convert into the figures when it comes to CO2 emission savings or fuel savings in turn. So this is true data. This is not a desktop analysis that we made. We can really prove this, and we always rely on third-party verified data on this.
Okay, very good. And do the ship owners care more about emissions or cost savings when they knock on your door?
Well, the first question is obviously what's the payback time of this investment. So this might be the starting point of or in the discussions. Good news to us was that the recent conference, the MEPC 83, set even stricter standards. So some of our clients enjoy now 50% less in their payback periods. So what has been 3 years in the past could be 1 or 2 years now in terms of payback times.
Very good. And were you happy with the outcome of the MEPC 3?
Extremely happy. I think the whole industry welcomes the decisions taken there. First time in the industry that we've been able to decide on global measures to reduce really the emissions.
And this is something that you're doing not just for new build, but also you can retrofit them on older ships as well, correct?
That's correct. And actually 2/3 of our business have been retrofits. So only 1/3 is picked up by new buildings. But quite interesting in the industry is that if you think of the overall naval architecture of the ships, the whole shape, general arrangement, hydrodynamics is taking different format now. Ships are built and designed to cater for the wind-assisted propulsion power. The deck hull superstructure is in the fore. The hull is prepared for maybe air lubrication system as well. So in combination with all these, we see different types of ships coming to the markets. And actually quite interesting phenomenon is also that some of the owners are not ready to make a decision yet to invest in the rotor sails. However, they make the ships what we call rotor sail ready. So the foundations are prepared already at the shipyards for installations that could take place at a later stage. So I would see that the industry is preparing itself for this type of phenomenons or technology, I would say.
And are there any particular ship types that are suited or not suited? Because I can imagine the container ships, for example, would be unsuitable for this technology given the deck space that's required for them.
Right. I mean, with container ships, it's simply a problem of not having deck space available. Height might be an issue, even though we have a tiltable rotor sails available. However, we have, of course, a program to investigate how could we also install rotor sails on board container ships. Different type of technologies could enable that. And actually, the second ship type that is not really suitable, or it could be suitable but not so lucrative, I would say, are the big cruise liners. Maybe the owners or passengers don't want to see huge towers even on top of the tall ships. So those are two ship types. All the others are really or in our addressable market.
Can this technology work well alongside, biofuels or even better electric ships?
Oh yes, I mean I would say that they are all complementary. I mean, I don't think there would be one without the other one. They would be run in tandem, if I would say so. And when it comes to electric ships, I mean, the sails are extremely well suited on an electric ship to work like a range extender on board those. So it is really complementary to other technologies, I would say.
What do you think would be the trickiest retrofit you've had to do to date?
Trickiest retrofit. I mean, technically, I don't see a big issue making a retrofit. Of course, we need to take into account visibility, stability, all the technical aspects. The retrofits are not really different from new buildings from our perspective at all. The thing is to prove really the advantages and the real savings coming out of the installation. And that is so closely correlated to the sailing pattern and the wind conditions along the routes. So it is not a challenge because we can make a very accurate estimate as long as we are aware of the ship's trading pattern. Of course, every time we get an inquiry, we make a quite thorough feasibility study and see what could be achieved with our installation. So this is the dialogue we need to do together with the client, and we need really be trustworthy on that one. I mean, this is not salesman talking. This is really scientist talking at that point,
Okay.
I would say.
And you mentioned as well that your largest one is 35 meters tall, and if I remember, about 5 meters wide.
Correct.
How do you size these sails for the particular vessels that they're going to be installed on? And how many do you install on a vessel? Because on the one behind you, there's two. I've seen some pictures with one. So, how many do you put on? What's the maximum you put on? And how do you decide? And, talk to me about that.
All right. I mean, the size depends really on the ship's size, the speed, the trading pattern, as I said, the wind conditions along the route. The amount is also dependent on the available fuel savings that could be achieved with different positioning on deck space, and free area is also an issue. We have a project ongoing where we have on order for 3 ships, 6 sails each, and they're all 35-meter tall, carrying products from France to US, crossing Atlantic. And our customer has made a very thorough 3-year study before they made the purchase that they can achieve even 50% savings on the route. That means that the whole ship will sail without the main engine, a big portion of the journey completely. So that'll be a very interesting installation coming up in the near future. We have really full-scale data from those ships, setting perhaps new standards in the future.
And it's typically side winds as opposed to you can't sail directly into the wind, similar as you can't with cloth sails. So would that require ships, if they had a headwind, to maybe zigzag the same way that sail ships have to do in headwinds?
Right. I mean, the direct headwinds are not really favorable for us. That's the only condition actually where our sales don't really work well. We put a lot of emphasis on the control automation. We have the artificial intelligence driven control systems. We have something called a sentient control, which is based on different type of sensor technology combined with the control system. It is fully autonomous. So the crew only needs to press a button and switch it on and switch it off. Basically, everything is done by the system. And when we combine our system with any voyage optimization system, I mean, they can all be bridged together. So then this combination can perhaps bring the best result to the ship owner. So, I mean, when we do this like voyage optimization with the wind assisted propulsion power, it is exactly what you said. It's not direct line from A to B. It is really zigzagging, taking into account the weather pattern conditions, waves, the big data from the weather conditions. And all this put together, the ship should arrive to the port just exactly on the right time. Not too early, not too late, with the best fuel economy achieved on the journey.
Okay. And what do you think shipping is going to look like in 2040? What will ships look like? Will they all have rotor sails like yours, or how do you think the market is going to evolve?
I think it's going to be a very common sight to have sails on board ships. Whether they are rotor sails or other solutions, there will be sails. I mean, like I said, currently we are doubling everything. The ships will look somewhat different. The new builds that are built catered for, they are tailored for wind-assisted propulsion power. When I look at the technologies today, there are these means to sort of survive the rules and reduce emissions, save the fuel costs, alternative fuels, biofuels, all these type of things. Or then there are other types of solutions that enables the ship move forward, which is where the wind power is actually really on top. So I would say that, I mean, what else would you do to create more trust besides the main engine that use wind currently? You have air lubrication. It doesn't give any thrust to the ship, but it saves fuel, which all these are significant. And like I said before, they go in tandem. They all contribute to each other, and the future will look like a combination of all this, in my view.
And what's the next maritime innovation you're keeping a close eye on?
We put a lot of emphasis on the software controls and all these type of things. It is really important that we can validate and prove the performance of the sail. I mean, it is a rotating cylinder making a little bit humming sign on deck, how much trust that really gives. And ship owners need to prove that to the regulatory bodies to overcome the rules and sort of comply with the saving targets instead of paying penalties. That's really something that we put a lot of emphasis, that we can prove in real time what is the true effect of our sail. So that it enables and helps the ship owner also to do their job with the regulatory bodies, for instance.
And what do financiers and insurers need to see before they bet big on wind propulsion?
We are all in the same community, I would say. I mean, we should all work together towards a more greener planet and take all these measures together. I mean, what we talk about is also recyclability of our product. Can it be recycled when the lifetime comes to an end? At the moment, what we see is that the lifetime of a rotor sail could be even longer than the ship's lifetime, which could create a second-hand market for the product itself. Different type of leasing solutions and all this type of would definitely surface in the coming years.
You mentioned at the start that you've worked across several marine firms and that you're third generation marine architect in your family. Is that what's kept you in the maritime world, or is it just love of the sea or tradition, or why do you stay in the sea world?
Well, I mean, it is obvious that my family brought me up with ships. I've been on board ships since I was a little boy, even a baby, and sort of live in that environment. breathing the spirit of the industry. So for me, it was very, very simple choice. I want to be part of this. I want to develop this industry further. And it is very nice to have traditions also in this life.
Fair. Yep. And what's one thing that people outside the industry always get wrong about shipping?
When you look at ships, it's okay, heavy smoke coming out of the chimney. It's polluting. Don't go on the aft deck of the ship. You get your shirt dirty and all this. And whereas it is really the industry is washing its face definitely at the moment to see the ferries calling ports with electric powers currently. There's no smoke coming out of the chimney anymore. It's getting very clean. And this is a global thing. It's not only happening in some countries. It is triggered and forced by regulations and these bodies. But like I said earlier, I mean, the green sentiment is really taking effect in the industry and in the end user, the client base. So they will start to require and demand ship owners to also take measures for a greener planet.
We're coming towards the end of the podcast now, Heikki. Is there any question I didn't ask that you wish I did, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
I think we covered pretty much everything already now, and I think it's important that besides all the technological aspects and the regulatory framework, I think it's quite substantial and interesting and very important for me, at least personally, and people in my company, and actually why not people in general, that we start to think about the environment. We are environmentally conscious, and it's not always the bottom line euro that counts. Also, some other aspects need to be taken into consideration. And this already we touched upon in the interview, but sort of still I'd like to highlight that issue for us all to understand this.
Great. Okay, super. Heikki, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
You can find me from Norsepower in our website, through our contacts, and that's where I am. Pleasure having discussion with anyone and discuss about the future with me alone or with my team. It is very interesting. Yeah.
Great. I'll put the link to the website in the podcast show notes. That way everyone, Heikki, will have access to it. Okay, Heikki, that's been fascinating. Thanks a million for coming on the podcast today.
Thanks, Tom. Thanks for your time.